Hello everyone, I'm Tanpraj from CSE graduating in Stephen College of Engineering. And in this presentation, we will see about the central limit theorem, a powerful tool in statistics. The central limit theorem is a concept in statistics that play a crucial role in understanding and analyzing data. It's a cornerstone of statistical inference, allowing us to make inferences about a population based on sample. This theorem is powerful because it describes the behavior of sample means even when we have limited information about the underlying population distribution. In this slide, we will see the definition of the central limit theorem. The central limit theorem states the distribution of a sample means approach a normal distribution as the sample size increases, regardless of the shape of the population distribution. In simple terms, this means if we take many random samples from a population and calculate the mean of each sample, the distribution of those samples means will be approximately normal, even if the original population data is not normally distributed. Sample mean, the average of a set of observations from a sample. Sample size, the number of observations in a sample. Normal distribution, a bell-shaped distribution that is symmetrical and has a mean, median, and is equal. In this slide, we will see about the importance of the central limit theorem. The central limit theorem is essential for various reasons. It forms the foundation for many statistical tests and confidence intervals, which are used to draw conclusions about population based on sample data. The theorem allows us to make inference about population parameters even when we don't have complete information about the population distribution, and it's a powerful tool for making data analysis. Confidence intervals, a range of values that likely contains the true population parameter. Hypothesis testing, a statistical method to test a claim about a population parameter. Data analysis, understanding and interpreting data to draw conclusions and making informed decisions. In this slide, we will see about the assumptions of the central limit theorem. The central limit theorem relies on few key assumptions. It assumes that the samples are random and independent, meaning each observation is selected independently of the others. It also assumes that the sample size is large enough, while the exact size depends on the population distribution. A general rule of thumb is that a sample size of 30 or more is usually sufficient for the theorem to hold. Random sampling. Each observation in the sample has an equal chance of being selected. Independent observations. The selection of one observation does not influence the selection of other observations. Sample size. A sufficiently large sample is required to hold the theorem. In this slide, we will see about the normal distribution and the central limit theorem. The central limit theorem is closely related to normal distribution. As the sample size increases, the distribution of the sample means approaches a normal distribution, regardless of the original population distribution. This is why the normal distribution is so important in statistics, why the central limit theorem is so powerful. Sample size increases. As the sample size grows larger, the distribution of sample means becomes more and more like the normal distribution. Normal distribution. The normal distribution is a bell-shaped curve that is symmetrical and has a mean, median, and mode that are all equal. Central limit theorem. The theorem states the distribution of sample means approaches a normal distribution as the sample size increases. In this slide, we will see about the central limit theorem and sample means. The central limit theorem is particularly useful for understanding the behavior of sample means. It tells us that the distribution of sample means will be approximately normal, even if the original population distribution is not normal. This allows us to make inferences about the population means based on the sample mean. Population mean, the average value of the entire population. Sample mean, the average value of the sample drawn from the population. Sampling distribution of the mean, the distribution of sample means from many samples of the population. In this slide, we will see about the central limit theorem and sampling distributions. The central limit theorem is fundamental in understanding sampling distributions. The sampling distribution of the mean is the distribution of sample means from many samples drawn from the population. The theorem states that the sampling distribution of the mean would be approximately normal, even if the original population distribution is not normal, as long as the sample size is large enough. Population distribution, the distribution of the entire population. Sampling distribution, the distribution of the sample means from many samples drawn from the population. Central limit theorem states that the sample distribution of the mean will be approximately normal, and even if the population distribution is not normal. In this slide, we will see the applications of the central limit theorem. The central limit theorem has widespread applications in various fields. It is used to construct confidence intervals for population parameters, conduct hypothesis tests, and make predictions about future events. The theorem is particularly useful in quality control, opinion polling, and medical research, where it allows us to draw conclusions about populations based on limited sample size. Quality control to monitor product quality and ensure consistency. Opinion polling to estimate public opinion on a particular issue. Medical research to analyze the effectiveness of treatments and medications. We'll see the limitations and caveats of the central limit theorem. While the central limit theorem is a powerful tool, it's crucial to remember that it has limitations. One limitation is that the theorem requires a large enough sample size. If the sample size is too small, the distribution of sample means may not be approximately normal. Another caveat is that the theorem assumes random and independent samples. If these assumptions are violated, the theorem may not hold. Sample size. The distribution of the sample means may not be approximately normal if the sample size is too small. Non-random sampling. If the samples are not random, the theorem may be. And we have come to the conclusions. The central limit theorem is a fundamental concept in statistics that plays a crucial role in understanding and analyzing data. It allows us to make inferences about populations and samples even when we have limited information about the underlying population distribution. This theorem is powerful because it describes the behavior of sample means, regardless of the shape of the population distribution. While it has limitations, the central limit theorem remains a cornerstone of statistical inference and is widely used in various fields. Sample means. The distribution of sample means approaches a normal distribution as the sample size increases. Statistical inference. The process of drawing conclusions about population based on sample data. Data analysis. Understanding and interpreting data to draw conclusions of informed decisions. Thank you.